Let's look at question 6. So question 6 is a circuit question. And here it says the end of a metal resistance wire is connected to a battery. So just a wire and a battery, very vanilla. There's no internal resistance. Nice. Power dissipated by the wire is 36 watt. So the wire itself will have its own resistance. It will get hot. Calculate the current in the resistance wire. So you can use P is equal to VI because I don't have the value of R. I don't know the resistance of the wire. But what I do know is you pass through the battery, you get boosted 8.0 joule per coulomb, 8.0 volt. Meaning when you pass through the wire, you will use up that 8.0 volt. So the potential difference across the wire is actually 8 volt. Battery give you 8, wire will use up all of the 8. No need to share with internal resistance. Very good. So P equal to VI. 36 is equal to 8 times I. So I here would be, we put 8.0. I also put 8.0 because we want to follow the SF. The value of I here will be 4.5 ampere. 2 marks. So if you use power is equal to VI, you get 1 mark, C1. And the substitution leading to the final answer is A1. We need to find the resistance otherwise. And in this case, I'm a bit lazy to find the resistance. VI can already. Okay, part 2. Number of free electrons that passes through the resistance wire in 50 seconds. So number of free electrons is N. Let's say this is N. And you know current is rate of charge flow, but it's the amount of charge flow per unit time. So this Q here is total charge flow, which means Q should be equal to N times E, where N here is the number of free electrons. Number of electrons. And this one is the charge of 1 electron. Okay, let's put it in. We know the current, 4.5. We can even multiply by the time, 50 seconds. We want to find the number. And the charge of 1 electron, I am going to, let's say you don't remember, so we flip to the front page and pray that your OneNote doesn't hang. Oh wait, you're not doing it on OneNote, you're doing it on a hard copy. Elementary charge E, 1.6 times 10 to the power negative 90. Okay, so we're going to go back to the question and do it. Do it. Where is it? Okay, here. There we go. 1.6 times 10 to the power of negative 90. So we can find N more. Always write your N into SF. Negative 90. So what I have is 1.41 times 10 to the power of 21. All right, pretty straightforward. What we're looking for is the equation, or rather basically if you multiply this 4.5 times 50 is equal to 225, you get C1 mark. Okay, and then if you divide by, you take this, divide by 1.6 times 10 to the power negative 19, this is another leading to the answer. This is A1. Okay, make sure to write here. We can only give you the A1 mark if your answer is written on the dotted line. So always write on the dotted line. We give you dotted line so nice, even fill in the unit for you. If relevant, this one got no unit. Okay, part 3, resistance of the wire. Sure, can VIR? Can. 8.0, current is 4.5. What is R? 8 over 4.5? Yep. 1.777777. Miss can put fraction. If you put fraction, you are GG. Cannot fraction. Please don't. So 1.7777, I put 1.8. Okay. Answer can never be fraction 2SF. Always 2SF. Unless the question give you values in 3SF, like the Doppler effect one, then can. Why sometimes they put 3-1? Just to see whether you have the SF awareness. So sometimes we have all sorts of awareness campaign, right? So maybe you can do a significant figure awareness campaign. So for this one, if you have V is equal to IR, you get C1. Yes. Leading to the final answer substitution is A1. There are many ways to do this. Maybe certain people want to use power. Let's say you use power is equal to I square R. So the power was 36, right? There, 36 watt. So I'm going to put 36 here. I was 4.5 square times R. So the answer is still 1.8. 1.77777777. You could even use P is V squared over R. So R will be equal to 8.0 square divided by 36. So 64 over 36 is still 1.77777. Okay, so up to you lah. Either way, right equation is 1 mark. Calculation to final answer is the 2nd mark. Right, easy. Part B. The metal of the resistance wire has a resistivity of 1.4 times 10 to the power of negative 6. This is rho. Cross-sectional area of the wire is 0.25. This is A. Determine the length. So this is the resistivity equation, rho L over A. Not given, you have to memorize. Okay, or you have to know. If you ask me, I think the occurrence is quite common, so you have to make sure you know. If not, you'll probably lose some marks or cannot do certain parts of certain question in the exam. All right, so RA over rho. We have the resistance just now. What was it again? 1.8. Teacher, can I write 1.7777? Can, but don't need to. You can copy whatever answer you write on the dotted line. Because whenever you copy something that is not here, my eye as an examiner would now have to go and find, is it here, is it here, is it here, is it here? I mark many paper very tired. So it will be easier for us if you actually use the number that you write on the dotted line, unless the question tells you to do something else. 1.8 here, so my eye will immediately go here. I see 1.8 here, I see 1.8 substituted here. I am happy, I move on. That's what you want your examiner to do. Happy and move on. And give you the mark. Millimeter. So 0.25 times 10 to the power of negative 3 because of the milli. But then it's square. So we need to square this. Okay? Because the mm square is for the unit, not for the 0.25. So this one will be 10 to the power of negative 6. Or you can just take negative 3 square like that lah, for your brain if you need to. And what we have for resistivity was 1.4 times 10 to the power of negative 6. Very temptation, I shall cut. So what I have left is 1.8 times 0.25 divided by 1.4. Type prefix long time. Can leave answer like that? No. 9 over 28, I don't even know how to look at SF. The answer is 0.32 meter. Okay, so 0.32. Easy. All right. For this one, you write the equation, you get 1 mark already. Substitute, leading to the final answer is A1. So make sure you convert correctly, lor. All right, pretty straightforward so far. It's been quoting equation, using equation. The complicated question was in front, other questions in this paper. So part C, oh, dang, a lot of lines. Circuit shown in figure 6.1 is modified by replacing the original resistance wire with a second resistance wire. Oh, I changed new wire. The second wire has a greater diameter. I'm going to write this down. Second wire is bigger in diameter. There's no other differences. Nice. By reference to resistance, that means I need to have a statement about resistance. State and explain whether the power dissipated by the second wire is more than, less than, or the same as the power dissipated by the original wire. So basically, I need to be able to decide whether P1 is bigger than P2 or not. We need equation. So I have a few. I could use VI, I could use I square R, I could use V square over R, but I gotta be smart. I have to use the value where the only variable is the resistance. Because I know the diameter change, maybe I can write this one first by reference to resistance. Let's get the first mark first. Point number 1. The resistance of the second wire is less because it has a larger cross-sectional area. I want to get this first mark first. So basically to show I know that resistance is rho L over A, so the diameter is bigger, A increase, meaning resistance will decrease. This is actually your M1. The idea that resistance of the second wire, don't just say resistance is less, or resistance of who is less. Okay? Or you could say A increase, so R decrease. Also can. So that means resistance will change, but I don't want another thing to change. So this means I cannot use this, and I don't want to use both of these. Not suitable, because I also changes. Current also change. So if current keep changing, you very sian one. Current change, resistance change. Which one change more? Don't know. So I'm going to use P is equal to V square over R. Teacher, V the same? Yes. V is the battery. V is the potential difference across the wire, which is here. Even if I change wire, I change the resistance, the wire is still going to be able to take the 8 volt because the 8 volt is the battery. No sharing. This wire is the only child, takes all the energy. Don't care whether the wire is thick or small or narrow or different material or short or long. Without internal resistor to share the potential, this wire is like, yo bro, this 8 is all mine. All mine. All mine. Okay? So I can say, and since the potential difference across the wire is the same or constant, the power dissipated is more. You would think the resistance is less, so less hot, right? No. This second wire is hotter because now, the resistance dropped. So, R decrease, P increase, inversely proportional. So, interesting. Doesn't mean that just because resistance dropped, then you get less heat. You need to see the connection. So always start with the change that we are doing. This is the change. How does this change affect the resistance? They even try to help you. This is your M1 mark. You state how the change affect the resistance first. Thicker wire, less resistance. Then you pause. What do they want you to relate it to? You are asked to relate it to power dissipated. So we need to come up with a connection. Do we use VI, I square R, or V square over R? Many times I've told you, use the one where the only thing that change is the thing that they change. So when they change resistance, actually the current also change one. Because V equal IR what? So if this is 8 and this one never changed, this I and then this R drop, so the current will increase. So I don't want my equation to have I because I don't want to talk about I. It's only 2 marks. I don't care about I. So I will use V square over R. V is always 8 volts, which means if R decreases, power dissipated is more, or power dissipated increases. This is the link. This will give you your A1. which means even if you just randomly guess it's more, but you never explain using the resistance, you will get no marks. Okay, and then mention potential difference across the wire is the same. But this one is in bracket lah, it's not that important. All right, so in a nutshell, resistance of the second wire is less because it has larger cross-sectional area. Make that link for your M1 and then conclude, tie this to this for your A1. So don't just sit there and stare at the question. Think a bit. The question always try to help you answer. The question will always try to direct your explanation. Your job is to fill in the blanks. How is resistance related to the change in diameter? Your job is the arrow, how to connect the dot. How is resistance related to the change in diameter? And then, how is the change in resistance related to the power? That is your job. Okay? The question will always tell you, these are 3 points. Please help us connect them. That's part C. Okay, let's move on to part D. Okay, now we have the same. We just add another battery because the battery is lonely. Sure. By reference to the current in the resistance wire, state and explain whether the addition of a second battery causes the power in the original resistance wire to increase, decrease, or stay the same. So now we don't change wire lah, we just add a battery. Interesting. This battery and this battery are parallel. So let's say the current here is I. I don't know what this I is. No, is it again 4.5? We calculated this one as 4.5 amps, right? 4.5 ampere. So 4.5 ampere passing through the wire. At this juncture, the 4.5 was split into 2. So here is I over 2 or 4.5 over 2, 2.25, I over 2. They both receive a boost of 8 volt plus 8.0 volt. They get boosted. But then they will combine again. So the current that is from here will combine and they will meet again in the resistance wire. So maybe I'll draw different color for you. This is the first current, this one is the second current. They split into 2, and then here they combine. Did the current change? No. Because why? The potential difference here is still going to be maintained at 8 volt. The only difference is the current is split. We split the current across the battery. So previously it was all the battery I passing through the entire wire. So all of I will pass through here, I. So the battery is like, bro, very tired leh. All I do one, all this boost I have to do, I have to give energy to this one I all the time. Now I got helper. You take half, I take half. So the first battery will give energy to I over 2. Second battery will give energy to I over 2. But like it or not, all the current will receive 8 volt. One teacher, very tired, so many number of students per unit time. If I got a teaching assistant, 2 teachers, and I share the students evenly, doesn't mean that the student learn double physics, right? It just means that now I'm less tired, I do less work, I supply energy to less current. Okay? Which means the power is the same because current is the same. So I'll say that the current in the resistance wire remains the same. So you can use P is equal to VI. V is the same, I is the same. So power stays the same. Power in the wire stays the same. You know the current is the same is M1. You know the power stays the same is A1. Okay, so this is the only difference. This is still going to be 8 volt. Minus 8.0 volt. Just like if you connect here to here, it's still going to be 8.0 volt minus 8.0 volt. Battery boosts the whole current arm. This battery get to share with another battery, but they also get boosted by the same amount. Okay? So that is this. It's a bit of a trick question because people tend to think, oh, more battery show more power, right? No. Depends on how you connect the battery. If you connect the battery this way, let's say you have two batteries like this with the same resistance wire, then this one is different story already. This is current. But when the current flows through the wire, it will get positive 8.0 bump, another positive 8.0 bump. So the potential difference across this wire is now 16.0 volt. So this is when the minus 16.0 volt. This is when the batteries are placed in series. Series, parallel, original. Okay, so if it's in series, then in this case, current will increase because you have more potential difference, or you could say P is equal to V over R, V squared over R. V increase, current increase, power increase when it's series. When it's series. Parallel, stay the same. All right. So the only difference between the original and the parallel is the battery will last longer. These two batteries can last longer. The only difference between you having two physics teachers and one physics teacher is that the physics teacher can last longer, not so tired. Okay? But that's it. So hopefully you understand the difference between series, where it's one battery after another battery, so you get double boost. Or you have two teachers running at the same time, just that the class size is smaller. Everybody gets the same amount of physics, teacher is less tired. Okay, so the current is shared across the battery. Power stays the same. That's it for the circuit question.